Alright guys, this is a quick video to try to show you how we properly use tools to measure things. In science, there are a number of different tools at our disposal where we want to make various kinds of measurements. What we see here is I've got two different kinds of tools that we'll use to kind of just get the gist of things. We have a graduated cylinder on the left, and it even includes a meniscus to try and show kind of what liquids do in a graduated cylinder. And this tool is measuring in milliliters. For the purpose of this video and for some of the examples you're going to do, don't worry about the fact that it has that unit of measurement. The other thing that we have is a ruler that's measuring in centimeters. Again, really just don't worry about those units right now. The main thing that we want to show you is that when you use a tool to measure, you're actually probably trained to use it incorrectly. Here's what we mean. Let's go ahead and first use the measurement of the graduated cylinder here on the left. If I were to look at this, I know I'm supposed to measure from kind of like the bottom of the meniscus there, kind of the bottommost point, and I have to kind of gauge where it is that that goes to. So I see that it kind of lines up really well with this tick mark right here. Knowing that this tick mark here is 40 and this one up here is 50, it looks like this counts by ones. So let's see, 40, 41, 42, 43, 44, 45. Yep, that looks like the middle of 40 and 50 here. 46, 47, 48, 49, 50. Okay, so this is 41, 42, right around 43. You're probably used to just saying, all right, that is 43. Usually we would put the units with it, but in this case, we really won't worry about that. There's actually a problem with this value of 43. This tool is used so that we can infer one digit past what we can read. That's how tools are actually meant to be used in terms of actually getting correct measurements. That also displays the correct number of significant figures. This counts by ones, 41, 42, 43. So that means this 3, that value is known. I can read that. I can see that on this scale. That value is not uncertain. That is not where we should stop with our measurement. We actually need to go one value past. So I'm actually going to kind of redo our measurement here. It is at the 43 because that's where the bottom of the meniscus is, but we need to go one digit past. We need to go to an uncertain digit. This is a digit that you basically have to guess. In this case, I think this is 43.0. I don't think that it's really above or below the line, at least I can't tell. I, as the person that's making this measurement, believe that it's 43.0. Someone else might say, well, I think that meniscus falls just a little bit above the line. So I'm going to say that's 43.1. Maybe there's somebody that thinks it falls just below the line. Maybe it's 42.9. Whatever it is, this digit here is uncertain. This is where we end up kind of having to make a guess as the scientist that's doing the measuring. And that's actually how you use a tool. You're supposed to infer one digit past what you can be certain of. Our kind of like value that we would report here for this graduated cylinder is 43.0. And it's okay if you want to say 43.1 or 42.9. That's totally fine. Here we have the ruler measuring in centimeters, and I see that this is a little bit different. It's going to measure from 3, and then way over here we've got the 4 value. If this here is at 3, 3.1, 3.2, 3.3, 3.4, 0.5, 0.6, 0.7, 0.8, 0.9, 4, yes, okay, so these are by single decimals. In the case of our graduated cylinder, all of the tick marks are representing 1 and increasing in values of 1. Here we see we're increasing by 0.1, just kind of an important distinction there. So I think, just kind of looking here, end of this, I'm going to go down somewhere around there. So this is 3.1. So this looks like that is 3.2. In this case, this value is certain. As before, what we had seen with the graduated cylinder, the 3 value, which is the ones value, that's what it counted by. So that's our last digit of certainty, and we went to the first decimal point to get to our first uncertain digit. In the case of our ruler here, things are a little bit different. We're counting by decimal values, so that 2 is actually a certain value. So I need to infer or guess kind of what is the digit that comes after. This is again a guess of sorts that you make kind of as a scientist based on just kind of what I see here. I feel like the line ever so slightly goes just a smidge past the 3.2. So I'm going to call this 3.21. Now somebody could easily say this is 3.20, and they're like, nope, it's exactly on that tick mark. It does not go past. Maybe somebody disagrees with me and thinks it goes a little bit further. Maybe it's 3.2 2. And that's kind of how measurements work. We always have that one digit of uncertainty. Now, what we're going to have you guys do here in just a moment is you're going to practice not only measuring to the correct number of sig figs, but then doing a calculation of measurements. So you're going to take two things that will require you to do measurements, like I've just done here with the graduated cylinder and the ruler, and then you'll have to do some kind of operation. In this example, we're being told to multiply. So this is where the video that you had watched previously will come in handy. You need to know how to do sig figs as it relates to calculations involving both subtraction and addition. And then there's a separate set of rules for multiplication and division. Here, we're going to do 43.0 times 3.21 and then come up with our answer. The thing that we need to do correctly here is make sure that our answer is reporting the correct number of sig figs based on these two different measurements we got. Because of the rules of multiplication and division, I need to know how many sig figs each of my numbers has before I do my calculation. So this first one, I know 4 and 3, those are non-zero numbers. It makes it really easy. I know those are significant. What is a little trickier here is this 0. Zeros can sometimes be significant, and it all depends on whether or not they're, where they're located, and then also whether or not there's a decimal point. In this case, I see that we do in fact have a decimal point, and even more than that, our non-zero numbers, the 0 falls to the right. So this is a right-hand 0, and there's a decimal point. That gives me all the information that I need, that this is in fact also a sig fig. So 43.0, that's actually a 3 significant figure number. And then our other number here, 3.21, all of those are non-zeros, so that's also 3 significant figures. Now normally when we do a multiplication or a division kind of calculation, we need to pick the fewest number of significant figures. Well, we have 3 sig figs and 3 sig figs. They're the same, so there's not one that is less. But what that does tell us is when we go to create this answer here, it needs to follow the rules of 3 sig figs. Let's go to a calculator and do this calculation really quickly. 43.0 times 3.21. What does that give us? 138.03. Now here's a problem with this value as I'm currently displaying it. If I just left it there and took what my calculator told me, this is where we can run into trouble. That's wrong. I'm not doing it correctly because right now the 1, 3, 8, 0, and 3, all of those digits are actually significant figures. That would be 5 sig figs. So that would be implying a level of accuracy that our tools don't have. They only have 3 sig figs of accuracy. So I need to scale back this number just a little bit. So let me go ahead and erase this value, and I need to report just 3 sig figs. So I'm going to remember that my calculator gave me this value. Now I'm going to take the first 3 significant figures from this, the 1, the 3, and the 8. We always work from left to right because that's preserving the most accurate part of the number. For example, if this was money that we were talking about, if you got $138 and you were supposed to get $138.03, it's not really that different. This 3 cents can kind of be eliminated. So 138, that's what we're going to report because it ends up being 3 significant figures. So that's just kind of a brief overview about how it is you use measuring tools to report a value that has the correct number of significant figures. And in this case, the really important kind of crucial part there is that you know to always infer one digit past what we can be certain of. And then the other thing that we need to do is practice our calculations with sig figs. So that is anytime that we're using addition, subtraction, multiplication, or division, we need to make sure that we're preserving the correct number of sig figs when we give our answer, because most of the time your calculator will give you far more digits than you should actually write down.